Alright, AP, this is sample exercise of 4.060. We are now writing equations for reactions. For each of the following reactions, write the formula equation, the complete ionic equation, and the net ionic equation. So you have two different equations to deal with. Go and press pause now, because here come the solutions. Start with the first one. The formula equation is KCl aqueous plus AgNO3 aqueous, reactive form AgCl solid, NKNO3 aqueous. And again, we know that this is going to form, the solid's going to precipitate out, not only from the question, from the problem, but also from the solubility rules in table 4.1. We have the complete ionic equation. Remember, any ionic compound dissolved in water will be present as separated ions. Okay, any ionic compound dissolved in water will be represented by ions. We have K plus aqueous, Cl minus aqueous, plus Ag plus aqueous, plus NO3 minus aqueous. All we've really done is taken these two substances and break them up into their component ions. That's basically all we've done, and represented them as aqueous. In the products over here, we have the precipitate. Again, table 4.1, or the question told you, AgCl solid. Okay, it's solid. Because it's solid, it's not dissolved. It's formed together into a pretty strict lattice crystal, and so it's not represented as separated ions, because in fact they are not separated ions. Water here does not have the ability to dissolve silver chloride. But again, K plus aqueous and nitrate minus aqueous. Now you see here I've identified spectator ion, spectator ion, spectator ion, spectator ion. You're like, why is that important? When we move down to the net ionic equation, we are going to be canceling the spectator ions, meaning if it's identified as a spectator ion, you simply don't write it in the net ionic equation. So what makes a spectator ion? Notice that K plus aqueous and K plus aqueous are both present on both sides of the reaction arrow. There's absolutely no change there. If there's no change, that means no chemical reaction has occurred. There was a reaction, okay, we know that because there's a phase change here, but K plus didn't participate in that. It was just watching, spectating. It's a spectator ion. Similarly, this nitrate anion, aqueous on both sides, no change. It's a spectator ion. This is important because once I've identified the spectator ions, I simply don't write them, and that gives me my net ionic equation. That's all I do. I just kick out the spectator ions and only include the things that actually underwent a change. So you notice on the reactant side, I have chloride aqueous plus silver plus 1 aqueous. Neither of those are present on the product side. Similarly, on the product side, I have AgCl solid. That is not present on the reactant side. Different things are present. There is change going on here. Alright, let's finish up with B. Starting with the formula equation, we have 3KOH in aqueous solution plus FeNO3 in aqueous. Reactive form, FeOH3 in solid state plus 3KNO3s in the aqueous. So the complete ionic equation, we're simply going to take anything that's aqueous, split it up into its individual, its component ions. So this becomes a K plus and an OH minus. Well, there's 3 of them, so make sure you balance it up. Okay, 3 of each. You also have Fe ion. Okay, what's its charge? Plus 3. Why? Because there are 3 nitrates, and nitrates are always -1. So in order to be balanced, that's a Fe plus 3. Again, it's aqueous because it's an ion. And then the nitrates. How many do you have? Oh, yeah, you have 3 of them in aqueous. This bad boy is a solid. It's the precipitate. It does not break up into ions. It comes out of solution. Again, there are 2 ways you could have known this, either by checking the solubility rules in table 4.1 or by reading the problem. So this is simply represented as FeHO3 solid. But then we go on to some different ions. 3 K pluses in the aqueous and 3 NO3 minuses in the aqueous. Cancel out all the spectator ions. Okay, so that would be the K pluses, the 3 K plus aqueuses. I have OH minus, but here are my OHs. And so OH has obviously undergone a change, so that's not a spectator ion. That definitely participates. Fe plus 3. Oh, but that iron, that Fe, is present in the solid, so that participates. It's not a spectator. But when we go to the nitrate, we have 3 NO3 minuses on each side, both in the aqueous state. They're spectators. They don't do anything. They just watch. So that's a spectator. I don't include that in the net ionic equation, which is just the hydroxides, the iron 3 cation, and then the solid iron 3 hydroxide.